Oh my God, that's unbelievable! The ground is cracking open, and it feels like hell itself is emerging. Yellowstone is on the edge of disaster as officials urgently call for evacuation due to signs of an imminent supervolcano eruption. This alert follows weeks of increasing seismic activity and noticeable geothermal changes. But what exactly caused this urgent action? How serious is the threat, and what could be the devastating consequences? Join us as we delve into this crisis, uncovering the scientific facts and potential global impact of a Yellowstone eruption. Recent alarming events have increased the urgency of the evacuation, indicating that Yellowstone's supervolcano is far from dormant. Heightened seismic activity and significant geothermal changes have raised concerns among scientists, leading to this decisive action. Yellowstone, known for its seismic activity, has recently experienced a noticeable increase in volcanic unrest. Scientists have detected ground uplift in certain areas, caused by accumulating magma and gas beneath the surface. Some areas have seen up to 6 inches of uplift, signaling a potential eruption. Alongside seismic activity, there have been significant changes in Yellowstone's geothermal features, including geysers and hot springs. Geysers that usually erupt at regular intervals have become unpredictable, increasing in frequency and intensity. For instance, Steamboat Geyser has erupted more frequently than usual, reaching heights of up to 300 feet. These changes suggest the underground heat source is becoming more active. Hot springs have shown significant temperature increases and color changes, indicating chemical alterations in the water. Steam vents have also become more vigorous, releasing greater amounts of steam and gas. In response, officials have issued warnings and advisories. The U.S. Geological Survey and Yellowstone National Park authorities are closely monitoring the situation with seismograph, GPS stations, and thermal imaging cameras. Their data indicates a significantly increased risk of an eruption. The decision to evacuate followed weeks of monitoring and consultation with experts. The first warning came when the Yellowstone Volcano Observatory raised the alert level from normal to advisory, indicating unrest. As activities continued to escalate, the alert level was raised to watch, signaling a potential eruption. Evacuating an area as vast and popular as Yellowstone is monumental. The park spans nearly 3,500 square miles, covering parts of Wyoming, Montana, and Idaho. Officials coordinated with multiple agencies to ensure an orderly evacuation, providing clear instructions, designated routes, and shelters. The evacuation involved a massive mobilization of resources. Park rangers, state troopers, and the National Guard assisted, ensuring public safety. Roadblocks were set up, and helicopters were used to survey remote areas and assist in evacuating those stranded. Efforts were also made to protect wildlife. As people left, scientists continued round-the-clock monitoring, ready to provide updates and additional warnings. The evacuation reflects the gravity of the potential threat, emphasizing the importance of staying informed and adhering to evacuation orders to ensure safety. This unprecedented evacuation raises many questions about the threat and what might happen next. To understand why these measures are necessary, we must delve into the science behind Yellowstone's supervolcano, its dangers, and why its activity warrants such drastic actions. Yellowstone's supervolcano is one of Earth's most formidable natural features, both in size and potential impact. Understanding its significance requires examining its definition, location, historical eruptions, and caldera formation. A supervolcano is a volcanic center with an eruption magnitude of 8 on the Volcano Explosivity Index, VEI, ejecting more than 1,000 cubic kilometers of material. These eruptions can produce massive ash clouds and lava flows, causing widespread and catastrophic effects on global climate and environment. Yellowstone National Park, spanning parts of Wyoming, Montana, and Idaho, is home to one of the world's most studied supervolcanoes. The Yellowstone caldera is the largest volcanic system in North America. The park's geothermal activity, including features like Old Faithful, draws millions of visitors annually, balancing natural beauty with underlying danger. Yellowstone has experienced 3 major eruptions in the past 2.1 million years, each significantly altering the landscape and environment. The Huckleberry Ridge eruption 2.1 million years ago ejected about 2,500 cubic kilometers of material, causing massive destruction and climate impact. The Mesa Falls eruption 1.3 million years ago produced 280 cubic kilometers of material, while the Lava Creek eruption 631,000 years ago ejected around 1,000 cubic kilometers, shaping the current Yellowstone caldera. Understanding the immense power and historical significance of Yellowstone's supervolcano highlights the need for preparedness. Scientists continue to monitor the supervolcano, using seismographs, GPS stations, and satellite imagery to track changes and inform emergency response plans. Exploring the science behind Yellowstone's supervolcano and its potential triggers reveals the dire consequences of these risks. The immediate impact of an eruption would be catastrophic, with far-reaching effects on both the local environment and global populations.